Hello students, welcome to the online lecture series of St. Andrews Institute of Technology and Management, Gurugram. Myself Sudhender Vats, Assistant Professor in Etce department. In today's presentation, we will see about the encoders and decoders, which is a part of Unit 2nd in Digital Electronics of Etce 4th semester. So, encoders and decoders are basically combinational circuits, that is, they have several inputs and several outputs, and the outputs depends only on the input at present time, that is, at any instant of time output is depending upon the value of the inputs at that particular instant. So encoders have n inputs and m outputs. Function of decoder is opposite of encoder. So encoders are basically used to encode data in some form so as to optimize the channel bandwidth. Using encoders, we will decrease the number of bits to transmit a particular set of data. For example, if I have n inputs and this is my n is to m encoder, so there would be m outputs. Okay, n inputs are given to the encoder and it will give m number of outputs. If let's say if I have is 4:2 encoder, that is, it is having 4 inputs and one of these inputs are high at one time. So this encoder will transmit one input at a time. So it will transmit 4 signals in a channel. If somehow I can reduce the number of bits, that is, at one time, if I0 is represented as 0 0 and I1 is represented as 0 1, I2 as 1 0 and I3 as 1 1, so at one time I would be transmitting only 2 bits, that is 0 0 or 0 1 or 1 0 or 1 1 for a particular input, that is, this will be transmitted for I0 and hence similarly this will be transmitted for I3. So at a time I am sending only 2 bits. So encoder converts our these 4 data, that is 4 input combinations, into only 2 outputs. Whereas as I have encoded my data and transmitted it, so at the receiver end I need to decode it, which is the reverse operation of encoder, and there I will get the exact input which I have transmitted in the original form. So decoder will decode that output of the encoder. So if I generalize this, if n is the number of input given to a encoder and m is the number of outputs, then the relation between the input values and output values would be n is equal to 2 raised to power m. That is, if I have n is equal to 4, if n is equal to 4, then it would give me m is equal to 2. That is, for 4 input values I would be using only 2 outputs. Okay, if I have a 8:3 encoder, then it will be having 8 inputs, that is I0 to I7, and you all know that we can represent 7 symbols or the 7 digits using 3 binary bits. That is, for 0 it would be 000, for 1 it would be 001, and as we go further, for 7 it would be 111. So I would require 3 outputs as 8 and n is equal to 8, so m comes out to be 3. That is, I would need 3 binary bits at the output, and if I am using a 3:8 decoder, it will convert these 3 inputs into 8 outputs. So let's see the types of encoder. First we will see them one by one. First is priority encoder, then we would be having decimal to BCD code encoder, then octal to binary, and hexadecimal to binary, which is nothing but as same as octal to binary, but the difference would be there in the number of inputs and the output. So first of all, let's see the priority encoder, which is one of the important topic out of all these. So if I decide the for priority encoder, if I have, let's say, number of inputs, and if I one or two or more than two are high at the same time, so I will assign them the priority, that which input would come out of the output based on the priority. Let's say if I7 is given the highest priority and I6 and I7 are high at the same time, so I7 will transmit to the output. Okay, if I6 is having a higher priority than I5 and I7 is 0, so between I5 and I6, I6 would be transmitted first. So this is how we would design a priority encoder. Let's say if I have a 4 is to 2 priority encoder, that is, I have 4 inputs and I am assigning them the priority from I0 has the lower priority and I3 has the higher priority. That is, the priority is increasing down from I0 to I3. That is, if I3 is high and it has the highest priority, so whether I0, I1 or I2 are high or low, it doesn't matter, I3 will transmit it first as it has got the highest priority. So let's uh, write the truth table for that, as I have 4 variables, that is I0, I1, I2, I3. Okay, so let's see, if I3 is high, let's say if I3 is high, so no matter what I0, I1, I2 are high or low, the output would be 1 1, because I3 would be represented as 1 1, I2 would be represented as 1 0, I1 would be 0 1, and I0 would be 0 0. So if I3 is high, so whatever be the status of these 3 inputs, only I3 would transmit at to the output. So Y0 and Y1, that is the output bits, would be high. Because it is a 4:2 encoder, output would be 2 and 4 inputs are there. Now let's see, if say I3 is low and I2 is high, I3 is low and I2 is high, so whatever will be the status of I0 and I1, that is, we don't care whether they are high or low, only I2 would be transmitted, that is 1 0. Similarly, if I1 is high and both these inputs I2 and I3 are low, so whatever be the input of I0, it doesn't matter, only I1 would transmit to the output, that is 0 1 would be transmitted. Similarly, if I0 is high and rest of the 3 are low, then I0 would automatically transmit it, that is, at the output I would get 0 0. If all of them are low, then I would get nothing at the output. Okay, so now let's make the K map for our output Y1 and Y0. So this one is for y1, and the four variables are I0, I1, I2 and I3. So for first case, when all of them are 0, it would be a don't care. Similarly, for second case, when I0 is 1, that is I0 is 1, so I would be having 0 0. I would be having 0, so I0 is 1 in this one and in this one, so I would be having 0 0 in both these. Okay, and now if I have I1 is equal to 1, that is I1 is equal to 1, so I can see that I1 is 1 in these two values. So for that, I1 is 1, so I will have so for I1 is equal to 1, I1 is equal to 1, that is in this case I1 is 1 and I2 I3 are both 0, so I am getting a 0, so it would be a 0 there as well. For I2 is equal to 1, that is for as I2 is 1 for both these rows and I am getting a high in Y1, so I will get 1 in all these 8 cells. Similarly, for I3 is equal to 1, I3 is equal to 1, and no matter what is the status of I0, I1, I2, that is for these two last rows, I will be having my function y1 as high, so I will put as 1 is already there in these cells, so in last 4 cells it would be 1. Now when I make the octets, 2 octets are possible. So for first it would be the value I2, and for second octet it is I3, so y1 becomes I2 plus I3. Similarly for y0, for first it is don't care, then for I0 is equal to 1, it would be 0, then for I1 is equal to 1, that is for these two cases y0 is high, so I will be having 1 and 1. Now for I2 is equal to 1, that is for, this is very important in this priority encoder, this particular instant, as at I2 is equal to 1, our function is 0, that is y0 is 0, so I will put 0 0 in all these 8 cells. For I3 is equal to 1, that is for last 2 cells it is 1, so I will put 1 1 1 1, but previously for the this case I have put 0 in all these, and in this case it is 1, so it would be don't care, so I would use don't care, because at the same time they cannot be 0 and 1 both, so it would be don't care. That is why I have put the don't care sign in these cells. So now when I do the pairing, I would be having a quad, and using these all don't cares I would be having a octet. Okay, so for the quad it will be I1 I2 bar, and for the octet it is I3, so y naught is I3 plus I1 into I2 bar. So these are my two logical function y0 and y1, which I can implement using and OR gate easily, because it can y1 can be implemented using a OR gate, and y0 can be implemented using one OR gate and one AND gate. So you can easily implement that. This truth table is very important. So you need to find out the function for output y0 and y1 carefully using these K maps. So next is decimal to BCD encoder. Decimal means we would be having 9 digits at the input, that is the decimal system, and we need to convert it into BCD code. As you all already know that BCD code would represent every decimal digit from 0 to 9 in 4 binary bits. So we would be having 4 bits at the output. So for 0 it would be 4 times 0, and similarly for 9 it would be 1 0 0 1. If now I see from this truth table, that is what would be the function of D, or what is D. So D would be input 8 plus 9. So if any one of these input is high, 8 or 9, D would be high. So D would be 8 plus 9. Similarly C would be 4 plus 5 plus 6 plus 7, wherefore these 0 to 9 are my input digits. Similarly, B can be 2 plus 3 plus 6 plus 7, and A would be 1 plus 3 plus 5 plus 7 plus 9, which you can easily see using this truth table, which is nothing but the binary representation of decimal numbers. So it can be implemented using these 4 OR gates. So this is how we can implement this decimal to BCD encoder. Okay. So next is octal to binary encoder. So in this octal system we would be having 7 digits and 3 outputs. So similarly we can find out the function for B2, B1 and B0. So B2 it would be 4 plus 5, that is this 4 plus 5 plus 6 plus 7. For B1 it would be 2 plus 3 plus 6 plus 7, and for B0 it would be 1 plus 3 plus 5 plus 7. So similarly you can draw this octal to binary encoder using 3 NOR gates. So this is how I can implement the octal to binary encoder using these gates. We have 7 inputs, and when we combine them and feed into OR gates, I would get the output digits B0, B1 and B2. Similarly, we can also implement our hexadecimal to binary encoder in the same manner, in which one inputs would be 16, that is from 1 to 15, and would be having 4 binary digits to represent our output. Now let's see the 3:8 decoder. So in decoder we would be having n number of inputs and m number of outputs, or we can say if it is a decoder, so I would be having more number of outputs than the number of inputs. It is just the reverse of, if these are my inputs n and these are my outputs, so m would be 2 raised to power n. So in this case m would be 2 raised to power n. Okay. So if we have a 3:8 decoder, that is at the input I have 3 digits A, B, C. So using these 3 digits I can represent 0 to 7 decimal numbers. Okay. So for the first 3 digits, that is if all of them are 0 0 0, then output Y0 would be high. If I have a combination of digits like that 0 0 1, then Y1 would be high. If I have 0 1 0, then Y2 would be high, and similarly if triple one all of them are high, then the Y7 output would be high. And I have put an enable variable as that. If enable is high, then only our decoder would work. If it is 0, no matter what the input is, that is output would remain 0. So you can take enable or you can ignore it as well, because the main working of the decoder is this truth table. So for Y7, that is this one Y7, the function is all of them are, Y7 is this one, that is all of them are high. So it would be A into B into C. For Y6, A and B are high and C is low, so it would be A B C bar. Similarly for Y naught it would be A bar B bar C bar. So I can implement this 3 to 8 decoder using 8 and gates, 3 input and gates, in which our inputs are A and A bar, B and B bar, C and C bar. So this is how I can implement the 3:8 decoder. So these are the basics of encoders and decoders. I hope you understand. Thank you very much.